Why did AI refuse to cross the network? It didn't want to get stuck in the traffic jam of data packets. Didn't laugh? Forget it. It was just a dad joke. Talking about AI and network, what we'd like to get started today in the short video is to look at what's going on in the AI and network industry. There's a development that I'd like to talk about, but before that, we'll look into the traditional networks. We'll look at how InfiniBand changed the network connectivity and data speeds. And then we will look into what is Ultra Ethernet Consortium, UEC. So let's get started. Traditional data networks are the foundation of digital communication. They are designed to connect devices such as computers, servers, various digital endpoints, enabling transmission of data across diverse environments. Key attributes of these networks include reliability, scalability, and flexibility. Traditional networks use Ethernet and TCP/IP protocols to ensure data integrity and facilitate integration across multiple systems. However, while they excel in general data transmission, traditional networks often struggle to meet the demands of modern applications like artificial intelligence and high-performance computing, or HPC, which require high-speed data processing with minimal latency. So in order to combat the limitation of the traditional networks, lossless networks were introduced primarily to tackle AI and HPC's appetite of the data processing and whatnot, right? So lossless networks addresses the limitation of traditional data networks by ensuring that no data packets are lost during transmission. This is particularly important in AI and HPC environments where data accuracy and transmission speeds are crucial. Lossless networks achieve this by using advanced error correction techniques and optimized transmission protocols, resulting in more efficient and reliable data flow. These networks are critical for applications that require real-time processing, high throughput, such as deep learning, machine learning. There are tons of applications. You can look into healthcare, you can look into autonomous cars, and a lot of related fields, in even now manufacturing, and also large-scale simulation models. Now, back in the day, this used to be taken care of by InfiniBand. Now, most of you might have heard about it. Recently has faded out kind of a little bit, but InfiniBand is a high-performance network technology designed for data centers and supercomputing environments. It was developed back in 1990s, I think late 1990s, to address the need for a faster, low-latency communication between servers, storage systems, surpassing the limitation of traditional Ethernet. InfiniBand provides low latency, high throughput data transfer, making it ideal for AI, high performance computing environments that require rapid data processing. Its architecture supports direct memory access, which is rather an amazing thing, reducing the CPU involvement in data transfers, which enhances the efficiency and performance in demanding computational tasks. Let me repeat that. So InfiniBand's architecture supports direct access to the memory, reducing the CPU involvement in data transfers, which enhances the efficiency and performance in demanding computational tasks. Now that's something amazing. But like any other technology, InfiniBand also comes with a set of pros and cons. So I've done my best to list quick three each, just for the sake of time. So let's look at the cons. Let's look at the pros first of InfiniBand. Now, it is low latency. So InfiniBand is designed to minimize latency, which is essential for AI and HPC applications that rely on real-time data processing. Second pro is high throughput. InfiniBand offers high bandwidth, allowing for rapid transfers of large data sets, a common requirement in AI workloads. And the third pro is the scalability. Now, InfiniBand can be scaled to support extensive HPC and AI environments, providing a necessary performance as workloads grow in the complexity. So it is, as you're scaling, as you're growing, definitely, this is a must-have for the data centers. And I bet most of the data centers now have InfiniBand. They're running on it, so it doesn't need much of an introduction. But since we are talking networking, we can't leave InfiniBand out. So now to the cons. Now, complexity. That's one of the key things at the moment. Nobody wants complex stuff. So InfiniBand's advanced features require specialized knowledge and to implement and maintain, making it more complex than traditional Ethernet. So not many resources available to support it. The cost, that's another thing. So high performance of InfiniBand comes at a premium price, and it makes it a lot more expensive than standard networking solutions, which could be a limiting factor for most of the organizations. Actually, some, not most, but yeah, of course, it is. The third one is compatibility, another con. So while it's highly efficient, it's still not compatible with the traditional infrastructure of the Ethernet, the network infrastructure. So it's not compatible everywhere. Now, I'm not saying it's not compatible anywhere. It would be. There are always workarounds, but in the end it's technology, right? But it's not compatible most of the time. That's why the adoption is a little slow. Due to other reasons like cost and complexity, lack of resource availability and whatnot. So definitely that plays a role. And of course, if you want InfiniBand to be in your data center, in your infrastructure, you have to have some compatible upgrades that you need to do in order for it to be supported. Now, having said that, now these were the two traditional models that were there, like Ethernet and the InfiniBand. It has been used since forever. Now, considering this, now businesses are now NVIDIA also have their own set of switches and whatnots, but again, that's monopolizing, and that's like it's never good, right? So the need for a unified approach to networking for the AI in particular and for HPC, this was been realized by a lot of organizations, and what they have done is they've come together and they have formed a consortium. They're calling it Unified Ethernet Consortium, UEC. You can get more information on, I think it's, I'll put the link somewhere, description or here, there somewhere. But yeah, so what they've done is they've come together. So they've got like the research institutes, they've got the technology companies, then they've got the people who are actually providing the information, then there are some companies who are actually working on it, like proper as a part of the program. You can get all the details on their website. So as AI and HPC applications becomes more prevalent, there's an increasing need for a unified approach for networking that can support these advanced networks and advanced workloads. So traditional networks are often insufficient for AI demands, while specialized solutions like InfiniBand, though effective, are not always feasible for organizations due to their complexity and cost. Unified approach would involve enhancing the existing networks, networking technologies to meet the needs of AI and HPC, ensuring high performance while maintaining compatibility and scalability. This would enable organizations to integrate AI capabilities into their infrastructure without overhauling their entire networking systems. So basically helping businesses save cost. So they don't really have to invest a ton of money to get started, right? If they want to adopt AI or HPC for their business needs. Now, what is UEC initiative? The Ultra Ethernet Consortium, or UEC, is an initiative aimed at evolving Ethernet technology to meet the needs of AI and HPC workloads. The UEC seeks to create an Ethernet-based open and interoperable model, interoperable communication stack, if I may say that enhances the traditional Ethernet capabilities in bandwidth. So there's bandwidth, there's latency, and then there's scalability. By focusing on these key areas, UEC aims to develop a networking standard that is robust enough for the demands of AI and HPC, yet flexible enough to integrate with the existing systems. That's music to my ears, and probably to a lot of CTOs and CIOs who are worried about what's going to happen with the AI adoption, or maybe just can't actually increase the AI adoption in many cases. So thanks, UEC. So UEC's approach involves collaboration among industry leaders, as I was saying before, to develop the standardized framework that can be widely adopted. Now, this framework will enable organizations to leverage Ethernet's widespread compatibility and ease of integration while benefiting from the performance. And of course, the enhancements for the AI and HPC will follow. Now, this is particularly important for the research institutes, for the universities, for the governments, for the banks. The use cases are many. For healthcare, of course, manufacturing, anybody and everybody, or any business that's processing a lot of data, or they're looking into a lot of metrics, and they're looking into how to optimize and how to analyze that data, or maybe they would want to start questioning it. So probably putting it into a vector database, and then using something like a local large language model to query that data. Now, another thing about this is you can actually build, you can actually quantize your any large language model to integrate with this whole approach. So what that can do for you is it can help you have your own AI, and in a quantized model, of course, because you wouldn't want to run a 70 billion or a 400 billion parameter model, which can you need at least 80 gigs of VRAM and probably 198 gigs of RAM, A100s, 8 of them, something like that. Heavy compute. You might end up spending $300,000-400,000 US dollars just to procure the hardware for that to run smoothly. So the best approach would be to get into quantized model and then build it, and then contact us or a company like us who can help you build that entire model to have it privately deployed. Having said that, I'm excited. That's why I said thank you, UEC. Moving forward, so what are the the advantages of this initiative that UEC is taking? Now, the enhanced, one of the advantages would be enhanced performance. So UEC wants to upgrade the Ethernet technology and that will result in significant improvements in bandwidth and reduced latency, making Ethernet viable for AI and HPC workloads. I'm confused. But let's see what they come back with. Because, I mean, no. That'll be a lot of investment that'll be done, but okay. I'm still excited. Don't get me wrong. The second thing is scalability. So the initiative ensures that the Ethernet can scale with the increasing demands of AI and HPC, allowing organizations to grow their capabilities without needing to invest in entirely new networking technologies. Let's see how that turns out, because I mean, businesses out there to make money, right? So why not? The third advantage of UEC's initiative is compatibility. This is a big one. By maintaining the compatibility with the existing Ethernet systems, UEC enhancements will allow organizations to integrate advanced networking capabilities without overhauling their current infrastructure. So maybe the backend network cable connectivities and whatnot, the Ethernet cables and all the network stuff would still stay there, and they might come out with some sort of another protocol that would run on the same cables. Interoperability is another advantage. So another focus of UEC is to create an interoperable communication stack that ensures enhanced Ethernet that ensures that enhanced Ethernet can work seamlessly with a variety of devices and platforms, facilitating broader adoption. So having said that, this is just what I have just told you about UEC is what my understanding is. So definitely what I read on their website, what I understood, what I figured that they would be doing with this is something like that's my view. So that's not on their website, but I figured to structure it to make it like easily understandable to the people watching this video. So huge disclaimer. This was just my interpretation of what was there on their website. You can go ahead, look at their website, try to get the information yourself, read it, understand it yourself, and consume it yourself the way you want to. Now, next, what's next for AI networking? So the future of AI lies in the continued evolution of technologies that can support unique demands of AI as well as HPC. Pretty much go hand in hand. AI applications can become more complex and data sensitive, which we see it's happening. Networks will need to offer even greater performance in terms of bandwidth. Now, if you think about the local networks, there can potentially be an option for the dark fiber providers that can jump on this AI bandwagon and actually start providing at least a point-to-point connectivities for the organizations that are adopting the network quickly. So, because they are pretty much open to any kind of bandwidth. So they can be one of the good ones. The other one is MPLS and DIA. Of course, telecom people will be super excited about this, but that's an expensive solution. That's short term. Let's see what UEC comes back with, whether they're upgrading the protocols, what they're trying to do. Maybe they're introducing software-defined networking. Who knows? Still in the works. So this entire initiative actually is quite exciting because it represents a significant step in this direction and providing a path for traditional Ethernet technology to evolve alongside AI. And they can go hand in hand because AI can support Ethernet to grow better, because AI is getting better, of course. So in the coming years, we can expect to see further advancements in both lossless networks and enhanced Ethernet technology, driven by ongoing collaboration between industry leaders, research institutes, technology companies, and customers, so on and so forth. These enhancements and advancements will not only improve the performance of AI in terms of the network, but also make them more accessible to a broad range of customers, organizations, businesses, ensuring that AI can benefit and the adoption becomes easier and can be utilized across industries. But this poses a bit of a question because this is directly contradicting with the AI security. But more on that in the next video. Thank you for hearing me out. Again, the views presented in this video are my own. I thought of sharing a little bit because this was something new I came across. So I thought of just putting up a quick video, sharing it with the community. Like, share, subscribe. If you don't want to like, if you don't want to subscribe, it's okay. Share it. At least somebody else will gain some traction, get some understanding. Thank you all. Cheers.